Hi friends, this is a quick lesson about histograms. This is another way to display data. And histograms are just like bar graphs. I know you guys have done bar graphs a ton in previous years. Histograms are just like that. The main two differences between histograms and bar graphs are that instead of drawing bars like this, on a histogram, your bars need to touch. So your bars, let me change color so it's a little easier, would need to look like this. So in histograms, your bars touch each other. Okay, so there's no space in between. The other thing that's different about histograms is the data is displayed in a range rather than each piece of data being displayed. And we call those bins. Okay, so I have some information here, resting heart rate, and I want to display this on a histogram. Okay, so I'm going to write that, histogram. Okay, so we've got a chart down here. Let's see if we can figure out how to do this. So this is how many beats per minute. That's going to be our x-axis, just like a coordinate graph. That's what we're going to put across the bottom. And it looks like our lowest beat is somewhere 66 is our lowest. So I'm going to start this over here at 65. And our highest is 98. Okay. So I'm going to label this line 100. So I'm not going to label I'm not going to put a bar for each heart rate because we only have one of each number. So it would be silly if I said, okay, here's our frequency over here on the side. And I've got 1, 2, 3, 4, and 5. If I made a bar graph or even a line graph for each of these things, I would have, 66. I would maybe put my graph here and then 70 and so forth. So all of my bars would be exactly the same height, and that doesn't really tell us anything. So what I want to do instead is create what we call bins, which is I've overlined here. So it's like a range of data. So I want to look at how many heart rates are between 65 and 70, how many people's heart rates were between 70 and 75, 75 and 80, 85 and 90, 95 and 100. 90 and 95, and then 95 and 100. Okay? Because that's going to be a better way to display the data that we've collected. So I'm going to go ahead and label the bottom of my graph in 5-minute increments here. 85, 90, and 95. And what I end up with is one person's heart rate is between 65 and 70. We have 2 people that are between 70 and 75. We don't have any heart rates between 75 and 80, but we have 3 here. And it's okay that there's a gap here and that they're not touching because we don't have any data for the 75 to 80 increment. We've got 85 to 90. We have 4 people, 3 people in the 95 to 100, and 1 person in the 95 to 100. Okay, so this is what our histogram data would look like rather than just being a flat line across. If we had made each individual heart rate a piece of data on our bar graph or our histogram, we wouldn't see very much. But now when we group them together, we can see that there's more good data here. Most of our data is right here in this cluster, which is the word we used in the dot plots. And we have a gap here and another smaller cluster here and a gap, okay? So this is a way to show data that has a lot of different points rather than doing a dot plot like we did before. So let's take a look at another example. What if we wanted to create a chart, a graph that showed the population of all the 50 states plus the District of Columbia back in 2010. This is census data from 2010. Whoops, back here we go. These are all of the populations for the United States. Well, we wouldn't want to plot every single one of these numbers. It would be a crazy amount of information. So what we're going to do is we're going to create bins, like we talked about on the last time. A bins is a range of data. So I want to look at the populations, and these are in millions. Of course, we don't have 4.78 people in Alabama. That's 4.78 million people in Alabama. So we want to create ranges of population so that we can better chart this. So I'm going to create ranges of 0 to 5, 5 to 10, 10 to 15, and so forth. So we would go through and collect our data on this chart here. So I'm not going to do them all, but just to give you an idea, Alabama, 4.78 million people, so that would be a tally in the 0 to 5 category. Alaska has 0.71, that would be a tally in that. Arizona has 6.39, that tally mark is going to go in the 5 to 10 bin. So you see how this works, and then once we get all this information, and I would cross these off after I've tallied them so that I can stay organized. Once we get all this information over here in the chart and our tally marks, then we can put our tally marks and our information down here in our histogram. So the population of states in millions is our label here at the bottom. This is our frequency, and then we would color in our bars right here to reflect what this data said. So when we do that, I actually have the finished one, we've got this ends up being what our histogram would look like. We have 29 states that have a population between 0 and 5 million. We have 15 states that have a population between 5 and 10 million. We have 3 states with a population between 10 and 15 million, and we have 2 states with a population between 15 and 20 million, and so forth. Now, the question I know some of you are probably wondering is, I've got my labels on the lines, but my bars are colored between. So this bar, is it 0 or is it 5? Well, actually it's a range, okay? It's going to be a range of, 0 to not quite 5. So if you look at my note that I wrote up here, the bins include the left value, so this value, but not the right value. So this 5, if a state had exactly 5 million people, that would go in this bar graph, okay? If a state had exactly 10 million people, that would go here. 15 million would go here. So we always include the number to the left, but not the number to the right. So what does that mean? That means that this bin here, right here, this bar graph, includes all states that have a population of 0 million to 4.9999 forever million. Once they hit the 5 million, then they get included in this bin, okay? So if I have a state that has exactly 15 million people, I'm going to put it right here, not here. Okay, so hopefully that helps you. And here's another look and another explanation as to why we use histograms. If we had taken the data from here and put it on a dot plot, this is what it would look like. kind of crazy and really difficult to read. So that's why histograms are a better choice for putting this type of data where there's a lot of variation and a lot of numbers into a histogram. We can change that data into, not change the data, but group the data into bins or ranges and put them on the bar graph like this. And again, just as a reminder, histograms are different because the bars touch and they include a range of data, a bin, rather than individual counts.